This question, I'm asking you to work this out as a graded homework. Let me do a question that is somewhat similar to it. Alright? I'm not going to give you this question directly. I'll work out this one that I wrote below. Now, this question that I asked you to do is the integral from 1 to 3 of g of x dx is 14. You should evaluate the integral from 1 to 3 of g of x plus 8 dx. Alright? Now, this is somewhat similar to it. I say the integral from 2 to 7 of f of x dx is 20. Then you should evaluate the integral from 2 to 7 of 5 f of x plus 50 dx. So I change out the numbers somewhat. Alright? We can see the similarity. Now, here, let's work this one out. Now, with this, you have two different functions in x added together. You can therefore separate it into two integrals. So this is the integral from 2 to 7 of 5 f of x dx. That's one. Plus, the second one is the integral from 2 to 7 of 50 dx. See that? Now, 5f of x dx. You know that when you have a number times of, you integrate a number times a function, you don't necessarily have to keep the number within the working of the integral. You could put the number on the left so that you integrate only the things on the right. So you have less confusion with the number mixed up in the working. So I'm going to put the 5 outside on the left, and we find the integral from 2 to 7 of f of x dx. Now plus, let's add a little more thing to this. This is the integral from 2 to 7 of 50. But what would be the power of x here if we show the power of x? Since we have dx, so we're saying that x is a variable. Well, if you remember your indices, you see that you can write x to the 0. Because remember, 50 means the same as 50 times 1. 1 is the same as x to the 0, so you can write it as 50 times x to the 0. Now, here, you have 5 integral from 2 to 7 of 50 dx. Notice here, we were told that the integral from 2 to 7 of f of x dx is 20. This is integral from 2 to 7 of f of x dx. So this 5 is multiplied by the integral from 2 to 7 of f of x dx. And the integral from 2 to 7 of f of x dx is 20. So it means that all this thing here is equal to 20. Alright? We can see that. So this is the same as 5 times 20. And you say plus. Alright. No, x to the 0. I didn't write the 0. Over here is 50x to the 0 dx. Now, here, we are doing a definite integral. So, we have 50x to the, and we add 1 to the power, 0 plus 1, and then divide by the new power, 0 plus 1, and we go from 2 to 7. Alright? Hope you're following. This is 5 by 20, which is 100 plus. Alright. This is 50x to the 1, which is just 50x, divided by 1. So you don't have to write that. From 2 to 7. So it's 100 plus. 50 times. Here we have 7 minus 50 times 2. See that? So therefore, this is something that I was working on before. Erase it. Here, this is 100 plus what? 5, 7, 35. This is 350 minus 50 by 20 by 2, 100. So, 100 minus 100 is 0. So the answer is 350. See that? So that is the answer. Note, remember we didn't add a constant of integration because when you're integrating and the boundaries are defined, the constant of integration subtract itself, as I explained in other videos. Now you see this part, let's look at it again. It could have been done by doing this. By saying you have 50 integral from 2 to 7 of x to the 0 dx, which is 50 times x to the 1 over 1. You add 1 to the power to get a new power and divide by the new power from 2 to 7. Right? And then it's 50 times x in one case. The upper boundary is 7 minus the lower boundary 2. So 50 times 7 minus 2 is 5. 7 minus 2 there. So what you have, 75350, it over here, it will only be this part. 350 minus 100 would be 250. So in this case, you will get 250 just for this part here. If you had added the 100 on the left to things and say 100 plus this, 100 plus this, 100 plus this, 100 plus this, it will be 100 plus 50 times 5, 250 to give you the same 350, right? So remember, you have number times the function of x to integrate. You can work with the number inside the integral, working the integral, but you don't have to. You can put it on the left of the integral sign and just deal with what you have on the right. But remember, you have to multiply the integral by the number that is on the left. Alright?